This video is going to talk about Newton's first law of motion, which is what causes changes in motion. So jumping into that, Newton's first law says that an object at rest will remain at rest and an object in motion will remain in motion. And here's a part that you may not have heard before, but is an important part: with constant velocity, unless acted on by a non-zero net force. So if we want to slightly oversimplify that, things keep doing the same thing unless force is applied. And again, that's an oversimplification. It's not a good formal definition, but it is a good rough idea. So something's staying still, it's going to keep staying still unless you push it. If something's moving along, it's going to keep moving along the same way unless you push it, or you pull it, or you apply some other force. So right here we see non-zero net force. That's a lot of fancy words to basically say non-zero, meaning not equal to zero. And net force means if you add up all the forces acting on an object, they need to be something that's non-zero. So net force, add up all the forces on an object. Non-zero, meaning that they will, it won't be equal to zero when you add those up. So an alternate way of phrasing this is that objects maintain constant velocity unless there is a net force greater than zero. And this is talking about the magnitude of the net force, by the way, not the direction. So objects keep their same velocity unless there's a net force greater than zero. Because if you think about it, being at rest means zero velocity. So I'm going to keep that velocity unless there's a non-zero net force. If I'm moving, I'm going to keep that velocity unless there's a non-zero net force. That brings us to this idea of inertia. And it's the resistance of, is an object's resistance to changes in its motions. And this is going to be proportional to the mass of an object. So something has a lot of mass, it's going to have high inertia. If you have twice as much mass, you have twice as much inertia, you're going to resist changes in your motion twice as much. So I want to just sketch a couple examples here so you get an idea. If I have a ball that's just sitting here and there's no forces acting on it, it's going to stay sitting there. If it's moving with a velocity equal to 10 meters per second, it's going to keep doing that forever unless there's some force that acts on it. If I come along to that same ball and now let's say I start pulling it 10 newtons to the right and I also pull it 10 newtons to the left, well, this is a zero net force because these two 10 newtons cancel each other out, so the ball will still keep moving with that same velocity. Or if it was at rest, it will stay at rest. The main place that we're going to look at it is for whether objects are at rest or whether objects are going to accelerate or not. We're going to look at their net force and see if that's equal to zero.